Assalamualaikum and very good day. I am Asrani Lid and I'm with the University Malaysia Sarawak UNIMAS. And the focus of my presentation is about investigating multi-channel performance in mesh wireless network on chip design. So this is the roadmap of my presentations, which basically consists of four main parts: introduction, methodology, result and analysis, and we'll end up with conclusion. Without further ado, first I would like to begin this presentation with introduction. The conventional on-chip network in this context are not scalable in terms of latency or energy consumptions, which causes execution bottlenecks. And recently, wireless network on chip or WNOC has been considered as a potential solutions to the scalability concern of the conventional multi-hop network architectures. The WNOC is a promising paradigm for the implementation of an on-chip interconnects that can support the modern many cores that demand of a high level of parallelisms. WNOC is the NOC architectures that integrate the wired and wireless interconnects to reduce the high latencies of wired planar communication with and express long-range wire channels. And the development of WNOC as a potential complement to the traditional NOC has been motivated by the advancement in integrated transceivers and millimeter wave antennas. And one of the key design elements that affect the overall system performance is its network cost is the architectural formations of WNOCs. For examples, the physical layout, link between the processor cores, the location of radio hub, and the number of wireless channels adopt over the WNOC networks all contribute to the WNOC performance. These figures illustrate the generic example of WNOC architectures of 2 by 2 or 4 radio hubs that are distributed evenly over the WNOC architectures. The additional of radio hub receiver to NOC tiles will enable the single hop communication between the distant tiles that would need the multiple hops in the traditional wired NOC network. The next presentation is on the methodology that has been carried out in this research. So this is the evaluation framework for this works. The evaluation of the investigated architectures use a cycle accurate system C based simulator called NOCSIMS. And as an input, mesh WNOC configuration is defined in the YAML files. Then the NOCSIM WNOC simulator is employed as the runtime engines, and afterwards, once the simulation is completed, the result and statistic can be obtained, which is in terms of the latencies as well as the network throughput. So this is the example of simulation output of the data provided by the NOCSIM simulators once simulation is completed. As can be observed, the result and statistics are in terms of delay and throughput of the WNOC system. So this is the simulation setup that has been carried out in this research. The simulation was conducted with 4 distinct wireless channels, which are 1, 2, and 3 and 4 channels. And in order to achieve a steady state, simulation in the placement of WNOC system was run for 100,000 cycles. So this is the investigated pictures with different wireless transceiver subnet clusterings. So now let's look into the result analysis for this work. So the latency is a critical performance matrix that could significantly influence the overall efficiency and responsiveness of the multi-core systems. And among the evaluated configurations, the WNOC subnet 1 is consistently delivered reliable performance across all channel counts, whereas YNOC with subnet 9 shows the greatest performance improvement with the channel scalings. These findings highlight that careful tuning of both and wireless channels of the architecture design can significantly improve the scalability and over performance of YNOC under synthetic traffic patterns. Network throughput is a fundamental indicator of YNOC systems to handle communication demand efficiently. When comparing the performance of the different subnet, the subnet 9 consistently achieve lower throughput than subnet 1 and subnet 4 across all channels configurations. This lower performance is because of the differences of topology or traffic distribution that make subnet 9 is more susceptible to congestions. Furthermore, subnet 1 and subnet 4 shows similar and better throughput performance, especially under high packet injection rates. And this suggests a more efficient communications pattern for better utilization of available channels. In conclusion, in this study, we have conducted a comprehensive evaluation of multi-channel YNOC architectures within a mesh topology that focusing on the impact on latency and throughput. The results demonstrate that employing the multiple wireless channels can significantly enhance the network performance, particularly under high traffic conditions. And among the evaluated configuration, the YNOC 1, subnet 1 is consistently exhibit the most stable and efficient latency performance across all channels. Meanwhile, YNOC subnet 9, although initially limited, shows the greatest improvements as the number of channels is increased. So with that, these are the main references for this research, and these are the rest of it. So with that, thank you very much for listening.